Good morning, class. This is just a little video to help you with your notes today. You're going to be exploring some other parent graphs besides parabolas, but we're going to take some notes on the parabola graph because it might help you with your other parent functions. Okay, so first off, we'll fill in the rest of this later, but we're just going to fill in this row today. I do want you to put this in the clips of your folder, because this is not something I want you to turn in. It's notes. I want you to have it to refer back to. So we're going to look today at parabola parent function. And the parent function is the simplest version of a function. It hasn't been transformed. It has its main key point or locator point at 0, 0 most of the time. So y equals x squared is the simplest parabola we can graph. And if we make a graph of that, it has its vertex at 0, 0. And parabolas, actually, if they have not been stretched or compressed, follow a specific pattern of 1, 3, 5, 7, 9, or odd numbers. And they just keep going. And what do I mean by that pattern? If I start at the vertex of any parabola and I move over 1, up 1, I get my next point. Then from that point, if I go over 1, up 3, I get my next point. From that point, if I go over 1, up 5, I get my next point. And I can follow that pattern for any parabola. Now you notice that's only half a parabola, so I have to go back and do the same thing on the other side. Go left 1, up 1. From that point, go left 1 more and up 3. And it's really easy to do these points because they're symmetrical. They match up with the one I've already done. And then over 1, up 5. You notice I've now got a very nice parabola drawn. And I just connect the dots and put the arrows. So that's how I graph a parabola that has not been stretched or compressed. As long as I can find the vertex, I'm good. We call the vertex HK. We looked at that last week. And finally, the general form for the equation. I'm going to write pretty small because I'm going to add some more things in this box. Y equals A, which is our stretch, compress, or flip value, x minus h parentheses squared plus k. And let's just define A, H, and K. A can be our flip if it's negative. Remember that if we put a negative value there, it flips it upside down. It reflects it across the x-axis. Got my T and my A mixed up. Sorry about the bad writing there. It stretches it if it's bigger than 1. Now really it's the absolute value is bigger than 1 because it can still be negative and be stretched if the value of A is bigger than 1, the absolute value. And the same thing with compression, but with compression the absolute value needs to be between 0 and 1. So we'll say 0 is less than or equal, well, not equal to, it's less than the absolute value of A is less than 1. If A is 1, there's no stretch or compression, and if A is 0, you just don't even have a parabola. It's all gone. All right, H is the x value of our vertex. In other words, it moves it left or right because the x-axis goes left to right. And K is the y value of the vertex. I'm going to do a quick example for you on a different video. So I'm going to close out this video, start one more video with a quick example.